So Feynman, many of you who have taken interest must be familiar with Feynman lectures in physics. Feynman also had lectures in computation. And the next slide, because we need to move a little fast. So in the next slide, so this is the first conference on physics and computation, 1981. Now you see what we are talking of. Computers got developed in its right, but the physics and computation interaction, the first conference was at MIT in 1981. And next slide. And here Feynman said this is very famous. And Feynman was a very informal person. So he said, nature isn't classical, damn it. And if you want to make a simulation of nature, you'd better make it quantum mechanical. And by golly, it's a wonderful problem because it doesn't look so easy. So, you know, all these people like to have problems which are not easy, which are challenging, and so on. And this got the race started. Till 1980s, nobody had ever thought of a thing like this, that we can use quantum. See, all your computers are effect of quantum thing anyway. You know, the transistor or the laser or all these integrated circuits, even when Shockley and Bardeen got the Nobel Prize for their transistor, it's all quantum phenomena. But what happened is quantum phenomena was already there, and then you were using the effects of it. But here he's saying, no, you use it as a quantum thing happening. And when nature is quantum mechanical, you will get to be able to get there. So you remember I talked to you about the things like hydrogen atom and helium atom and so on. He says, just put them and get them. And you will therefore see in the future that one of the big things, hope from quantum technologies, is that we can discover new things in nature, because we would know how nature actually works. See, so far science is about understanding nature. So we are at that level where we are trying to understand how things work. Now, what people are saying, once you understand quantum technology, quantum mechanics and build quantum technologies, you can build new things. So new materials, new things, and this is the big hope that is there, and I'll probably be sharing about it. But this is why the excitement about quantum is, that we are now moving not to just understanding what nature is, but creating, I could say, competitive products with nature. Many of you, if you have followed the general news, you would have seen that 2020 is the year when man-made stuff has become more than natural biomass. And this is called the Anthropocene age, where what man has created. And you've seen we have created so many synthetic things. Plastic is not found in nature. We have created plastic. So many things are not found in nature. We have created. But once we understand the quantum nature, huge things going to happen, and I'll be talking about them in the next few slides. But this is the turning point. So from 1980, when they started talking about this, the strive was for quantum supremacy. And as we said, China has a very interesting professor called Tam or something. He's supposed to be the big man in China in quantum computing. And they just created quantum supremacy, where their system would did something in minutes that would take more than 2 billion years by the world's third largest supercomputer, they're saying, because that is the one they have. Next slide, please. So this is what I talked about in the beginning, that in Nature magazine, they put it as a cover story because it's such a big thing that we are talking about quantum supremacy. The quantum computer is doing in 200 seconds what the fastest supercomputer would do in about 10,000 years. Some people challenge that not 10,000 years, it will take less, but still the scale is very, very different. Just like the slide rule and the computer of those days. Next. IBM challenged this, but we can go on. Next slide, please. John Preskill is the professor from Caltech, who in 2012 had coined this term, quantum supremacy. Because see, from 1980, they were looking at building quantum computers. The first few computers that were built were like, of course, they were very difficult, but they didn't do any serious calculation. Till a few years ago, IBM had a computer which could only factorize 15 as 5 into 3. So that was of no use. So he says it's not merely demonstrating quantum computers. You have to get quantum computers to do something which no existing computer can do. And that's why he coined the term quantum supremacy. And Google took to it and Google chased it. IBM has been at it, but never chased this quantum supremacy. Now, of course, China chased this quantum supremacy and US is now reacting to it. Next. So I have this nice thing to give an example of what does this mean to say that it is something. When we say that it's something completely different. So here is a very interesting example. You know that the distance from the sun to the earth is 93 million miles approximately. The speed of light is about 186,000 miles per second. So the question is, how much time does light take to come from the surface of the earth to the surface of the earth? And I'm using the phrase surface of the earth because between inside the sun and going to the surface of the sun is another story. So 93 million, 186,000, you divide, you get 500 seconds, which is 8 minutes, 20 seconds, which is the right answer. But try to do this using the Roman arithmetic. You know, the Roman characters are used in school to say class 1, 3, 5, class 10 is X, class 9 is I before X, and so on. So this is a Roman method. Now you use the Roman method to write 93 million, you won't be able to write it easily. Write 186,000, that's not easy. You try to do the division. You can't, because in Roman arithmetic, there is no division operator. And therefore, you will have to keep on subtracting 500 times. If you could write in Roman, subtract in Roman 500 times, then you would get it. Whereas in the Hindu arithmetic, we could. This is the point of supremacy. That the quantum computer can do it in a couple of 100 seconds, which the alternative computer would have taken a longer time. And I've just used this analogy to show you that when we have two different systems, the results can be completely different. And it is not only on computers, but even on arithmetic, which is, of course, basic computing. Next slide. So what is the promise of quantum computing? And we are using the word promise because very little has really been demonstrated. There are people are actually using quantum computers today. There's a very famous company called D-Wave from Canada, Vancouver, which is using, and they're using it for some practical applications. But the real excitement is about the promise of quantum computing. See, let me again make a diversion. All of you with your class 8, class 10 physics would have known how to calculate the escape velocity of an object from the gravitational field of the Earth. And if I recall, it is about 8 miles per second or 11.2 kilometers per second. This is known from very early Newtonian times or whatever, when you could calculate the escape velocity. Hadn't been achieved. It was achieved for the first time, at least in terms of well-known records, on that 6th of October 1957, when Russia launched the Sputnik. Till then, everything that goes up must come down. But they achieved the escape velocity. And today, of course, as you know, space is a whole area. Space, the companies which are space-based, aerospace companies, Lockheed Martin, many others. That's the same thing I'm trying to say, that from a fundamental principle of physics to creating the technology to do that, to creating a whole economy around it, we move to space. So that is what we are trying to see. What would be, if and when we could achieve the quote-unquote quantum supremacy and do it reliably in a routine way, just like satellites are now today launched in a routine way. And there are various ranges of satellite, from large to small to big to this thing. Even school children are creating their satellites and launching them and so on. So we are looking at a little bit of future. So we are talking about 15 to 20 years from now for this to be commonplace. But during that time, the people who will be involved will be the experts and leaders in it. So what is it that we are expecting to achieve from quantum computing? And say it is quantum physics, quantum chemistry, quantum biology, including finance, and so on and so forth. And the reason is that what quantum computers are going to do are going to talk about challenging problems which we can't do so far.